Hi subscribers and visitors. Here's the best evidence I've ever heard regarding a logical look and scientific assessment of the debate between evolution and intelligent design by Mark Eastman. Dr. Mark Eastman. Be sure to watch Part 2 for the conclusion. To add, I missed the start where Mark says the title of my message tonight is From the Dust of the Earth. Let's get it started.
Is from the dust of the earth. For thousands of years, there's been two worldviews. Genesis 1:1, in the beginning, God created the heavens and the earth. Genesis 1:1 is an incredible piece of scientific knowledge that says that prior to the existence of time and space and matter, there was a creator, a transcendent creator who, through his incredible power and knowledge, created the heavens and the earth, space, time, and matter. The other view is expressed by Carl Sagan in his book Cosmos, says the cosmos is all that is, or ever was, or ever will be. So you have the view that a transcendent, supernatural creator who existed before the universe created the earth, the universe, and its life forms. The atheistic or the materialistic worldview is that the universe is all there is. There is nothing outside the dimensions of space and time, and that everything that exists is a result of natural forces within the space-time domain. As a result of billions of years of accidental circumstances, the galaxies, the Earth, and its life forms arose without any interference of an extra-dimensional supernatural being. In Genesis 2:7, it says this, "And the Lord God formed man from the dust of the ground and breathed into his nostrils the breath of life, and man became a living soul." So there's two views on how man and the life forms on planet Earth got here. The first view, which I call the intelligent design formula, says that matter combined with energy, combined with information, concepts, know-how, blueprints, biochemical expertise is what was necessary to produce living systems. And that, of course, is the creation worldview. The evolutionary formula for life basically says that matter plus energy plus chance chemistry, what some would call chance stochastic chemical processes, acting over billions of years of time, produced all of the life forms that we see on planet Earth. So those are the two worldviews. When we talk about living systems, living beings, we need to define a little bit some of the basic characteristics of living systems. What is the difference between, this pulpit and the person standing behind the pulpit? And there's actually some quite basic differences that we can look at that define living systems. First of all, living systems are able to process energy. They're able to take nutrients from the environment, utilize the energy from those nutrients to perform useful work. That's one of the defining characteristics of living systems. Secondly, living systems must have the ability to store information within their cellular structure. Information that is necessary for the metabolism and the reproduction of the organism so that they can make copies of themselves and pass that information on to the next generation. So storage and also retrieval of that information is necessary if you're going to make copies of yourself. So that's a second thing. And another thing that is quite unique to living systems is self-reproduction. No machine ever made by man has ever been able to make copies of itself. You'll never find two cars in the parking lot snuggled up next to each other overnight, the next day producing little baby cars. It just doesn't happen. So living systems are capable of storing, processing energy, using nutrient energy from the environment to help them stay alive, metabolize, reproduce themselves. They're able to store information within their cellular structure. The information is used to make copies of themselves. The information is used for metabolism. It's used for repair of injured structures. And of course, they're able to self-reproduce. These are three characteristics which define living systems and separate them from inanimate, non-living structures. And when we talk about the origin of life, we're really talking about two different aspects two different problems in the origin of life. Living systems are comprised of two main components. They're comprised of hardware, chemical hardware, and they're comprised of software. The hardware in living systems is made up of a number of very complex chemicals. Proteins is the most abundant chemical that is found in living systems. Proteins are strands of amino acids bonded end to end, and proteins function to provide the structures in your body: bones, teeth, hair, skin. They're also involved in metabolism. Enzymes which accomplish the chemical reactions in living systems are proteins, and they make up the majority of what I call the chemical hardware in living systems. The second structure is DNA, deoxyribonucleic acid. DNA is a very complex molecule we'll look at in a moment that is the molecule that all living systems on Earth use to store the information necessary to produce all life forms on planet Earth. It's a very complex molecule. And that is critical to explain the origin of DNA and proteins if we're going to explain the origin of life using any method, whether it's evolution or creation. RNA, ribonucleic acid, is another very complex molecule that the information from DNA is transferred to RNA, and then RNA then transfers the information for the production of proteins. We'll look at that a little bit later. And finally, in living cells, there needs to be an envelope surrounding the cell that holds all the materials inside and keeps it from oozing out into the environment. So this is what we would call the cellular hardware. This is a photograph showing some proteins within the cell wall on the surface and within the cell wall of a living cell. In 1953, a major discovery was made by James Watson and Francis Crick. James Watson and Francis Crick were working for years to try to discover the structure of the DNA molecule, which is the molecule that stores all of the information in all of living systems on planet Earth. They won the Nobel Prize eventually for elucidating the structure of DNA, and this is a photograph of them. And what they found was that the DNA molecule is made up of 4 chemical bases: adenine, thymine, cytosine, and guanine. And these 4 chemical bases are attached to a sugar molecule called deoxyribose. And long strands of deoxyribose with these bases form a structure that looks something like a ladder which has been twisted on itself. 2 strands of DNA attached to each other by hydrogen bonds and twisted like a ladder, forming what is called a double spiral helix. This molecule is very tightly packed and wound up inside the cells of every living organism on Earth. And it stores the chemical instructions, the information necessary to produce hearts, lungs, eyeballs, brains, teeth, liver, kidneys, everything in every living system on Earth. DNA is compacted in the cells into what are called chromosomes within the nucleus of our cells. Chromosomes are very tightly wound packages of DNA. This is a photograph of this is actually an electron micrograph of the X chromosome in human beings. Very tightly packed, condensed portions of DNA molecules, what makes up these chromosomes. Now DNA, deoxyribonucleic acid, in order for an organism to make copies of itself, it needs to duplicate the DNA molecules. A single DNA molecule can reproduce itself into 2 DNA molecules in a very complex process involving approximately 20 protein enzymes. A single cell can make a copy of itself, approximately 6 billion nucleotides, in about 15 to 20 minutes. Now, 6 billion nucleotides is vastly more information found in your average computer hard drive. And yet it copies itself with an accuracy which is greater than digital computers today. The information on the DNA molecule is then transferred to a molecule called RNA, as I mentioned, and then RNA ultimately results in the production of proteins. Now, the interesting thing about the DNA molecule is to make copies of DNA, you need proteins. But you can't make proteins until you have DNA. And this is one of the fundamental paradoxes of life, is you can't have DNA until you've got proteins, but you can't have proteins until you have DNA. And we'll look at that a little more carefully as we go along. Now, the cellular software is contained or stored by the DNA molecule. The DNA contains coded instructions for all of the structures in all the living systems on planet Earth. And these instructions are carried by the DNA molecule in a chemical fashion. It is stored digitally in a mathematical form. It can be evaluated with mathematical principles. The code is error correcting. When a DNA molecule makes a copy of itself, when one DNA molecule results in the production of two new DNA molecules, a protein goes along the edge of the DNA to feel for the proper structure. If it finds an incorrect building block, it removes the building block and puts the correct one back in so that you get a perfect replication of the DNA molecule. So the DNA code is digital and it's error correcting. And the information in the DNA molecule is redundant. There is more than one gene in the human cell for the production of insulin. There's, in some cases, multiple backup genes for very critical molecules within the genetic code. When the space shuttle takes off, it usually has 4 computers on board. It has one main computer and 3 backup computers in case the other computers fail. The DNA molecule is the same in living systems. The information is redundant. There's multiple places in the genetic code where critical molecules are made, where the information is stored. And finally, information on the DNA molecule is overlapping. They have found segments of DNA where more than one protein can be produced from a single segment of DNA. Let me give an example, a way to think of this. There are fragments of DNA that have been discovered that produce, say, human insulin. Well, they've also found situations where that same segment of DNA that produces insulin might also produce an entirely different functional protein a little further down the line, but overlapping to produce something, say, like hemoglobin. So the information on the DNA molecule is digital, it's error correcting, it's redundant, and the information is overlapping. This is incredible. There is no computer system that uses information in this fashion. So that's a little bit brief about the hardware and the software. Now, the evolutionary worldview teaches that life arose by the process of spontaneous generation. That is, non-living chemicals, by chance, came together to form living systems on the Earth in the distant past. Many people give credit to Charles Darwin for this concept, the idea that somewhere in a puddle chemicals came together by random chance, but it actually was proposed about 24 centuries before Darwin by a Greek philosopher by the name of Anaximander. He first proposed in the 6th century BC that life arose in mud as little microbes, and they then evolved over time into more and more complex organisms. So Darwin actually ripped his theory off from Anaximander about 24 centuries before. In the Middle Ages, people believed that microbes, bacteria, arose from broths, soups and broths, because they noticed that when you left soup out for a few days, that there were critters inside of it. And so they just assumed that the critters had evolved out of the primordial soup there on the kitchen, in the kitchen, and arose to form bacteria. They also believed that rats arose from trash, because they noticed that when you put the trash out, if you leave trash out for a few days, rats show up in the trash. And so rats spontaneously evolved out of trash. And of course, they believed that fruit flies arose from aging fruit, because they noticed when you leave fruit out for a few days, flies show up. So that's the concept of spontaneous generation. Now, in the 1800s, this gentleman, Louis Pasteur, wanted to put to rest the idea that non-living chemicals, non-living things such as trash and broths, could spontaneously generate living systems. And so what he did was an elegant experiment where he took some broths, chemical broths, and he boiled them to kill any microbes that might be in there. And he used a gooseneck or an S-shaped glass flask and put a little bit of cotton inside the tip. And as long as he left the cotton there and didn't break off the glass neck, no organisms were generated at all inside the broths. They remained sterile. However, if he broke off the neck, within a couple of days, organisms started growing inside the broths. And so he proved that spontaneous generation does not happen, that the organisms come from the air and they get into the broths. And he's credited with blowing away the notion of spontaneous generation, at least for a while. A few years later, Charles Darwin, in 1859, published his book, The Origin of Species. And in his book, he proposed that, indeed, living systems did evolve from non-living systems in a body of water somewhere on planet Earth, only he didn't believe that spontaneous generation occurred quickly. He believed it occurred over a long period of time. And he said in his book, "It is often said that all the conditions for the first production of a living organism are now present, which could ever be present. But if we could conceive in some warm little pond with all sorts of ammonia and phosphoric salts, light, heat, electricity, etc., present, that a protein compound was chemically formed, ready to undergo still more complex changes." So Darwin basically proposed that a long time ago on planet Earth, there was a primordial goo, that energy from various sources, lightning, sunlight, etc., acted on chemicals found in a body of water somewhere and gradually produced protein molecules, which then evolved further into full-blown living systems. Now, during the time of Darwin, they didn't know what DNA was. It hadn't been discovered yet, but they knew that living systems at least involved protein. And they felt for a while, for over 100 years, that protein was the basis, the fundamental basis upon which living systems were built. It wasn't until Watson and Crick, about 100 years later, that they discovered that there was DNA and RNA as well. So you have the concept then by Darwin of the primordial soup, primordial goo. Well, at the turn of the century, most scientists did not believe in spontaneous generation because it was felt that life was just too complex for it to happen by chance. But the spontaneous generation debate heated up again in 1924 when a Russian biochemist by the name of I.A. Oparin proposed that life had arisen from simpler molecules on the lifeless Earth under much different atmospheric conditions than exist today. He proposed that spontaneous generation, life coming from non-life, had occurred gradually over a period of millions and millions of years. In 1929, an English biologist by the name of J.B.S. Haldane proposed that ultraviolet light acting on a primitive atmosphere containing water, ammonia, methane, and hydrogen produced oceans with the consistency of what he called a hot, dilute soup containing the building blocks of life. Now, Haldane and Oparin knew that life could not arise spontaneously with the atmosphere that we have today. And the reason is oxygen. Oxygen is very destructive to the building blocks of life. If you take oxygen and you expose oxygen to proteins or to the building blocks of DNA, it destroys them, it oxidizes them, and they become useless for the production of living systems. And so Oparin and Haldane proposed that life had occurred spontaneously under very different atmospheric conditions. They said that there was methane, CH4, ammonia, NH4, water, probably some carbon dioxide, as well as hydrogen gas, but no oxygen, because oxygen devastates the possibility of spontaneous generation. It wasn't until 1953 that their theory was put to the test. In 1953, a graduate student named Stanley Miller was challenged by his professor, Harold Urey, to test the Oparin-Haldane hypothesis. And so what he did was he created a system of glass flasks in which he circulated ammonia, methane, water, and hydrogen, circulated it through this system of glass flasks. There was no oxygen in there, however, and he developed a certain part of the glass flask where he had a spark, two metal electrodes, and he was able to create a spark between the electrodes to electrify these gases. After about a week, he noticed that the mixture turned kind of a cloudy reddish color. He analyzed the mixture, and to his amazement, he was able to produce some of the building blocks of living systems by this random molecular spark and soup experiment, as it's called. But when we look at the products of Miller's experiment, we find an interesting mix. 85% of what Miller made was tar. The same stuff that the roofer used today to repair some cracked tiles on my roof. Tar. Black, gooey stuff. 13% consisted of carboxylic acids. Carboxylic acids are very complex carbon, oxygen, hydrogen-containing chemicals, but most of them are not used in living systems. 1.05% of what he produced was glycine, one of the amino acids, one of the 20 amino acids found in living systems, and 0.85% was alanine, another amino acid that he made. Eventually, it was discovered that he produced a very small trace amounts of aspartic acid, glutamic acid, and beta-alanine, and a few other amino acids that are found in living systems. When Miller did this experiment, it was hailed as proof that random chemistry can produce living systems. I teach at the Calvary Chapel Bible College, and recently I was teaching up there, and one of the students came up afterwards and said to me, "Isn't it true that some guy in 1953 produced life in a test tube by sparking it?" And of course, Stanley Miller did not. But it was amazing to me how effectively students have been brainwashed into believing that this experiment was virtual proof that living systems can be produced by chance chemistry. Let's look at some claims by some chemists about the significance of the Miller-Urey experiment. Robert Shapiro, a PhD biochemist from New York University, wrote a book called Origins, A Skeptic's Guide to the Creation of Life on Earth in 1986. And on page 105, he said this. He said, "Let us sum up. The experiment performed by Miller yielded tar as its most abundant product. There are about 50 small organic compounds that are called building blocks of life. Only 2 of these 50 occurred among the preferential Miller-Urey products. So 2 of the 50 chemicals necessary to build an amoeba, a single-celled organism, actually occurred inside the Miller-Urey experiment in significant amounts." When I was in college, I was told that other experimenters after Miller and Urey did this experiment were able to produce the building blocks of DNA, the nucleotides that I showed you earlier. I was told that it had been done. In fact, in my biochemistry textbook that I used in medical school, in the introduction, it spoke about the origin of life, that biochemists had actually been able to do this in the laboratory. Using spark and soup type experiments, they've been able to produce the nucleotides, the building blocks of the DNA molecule. Well, in 1986, Robert Shapiro comments on this. And he says, regarding the nucleotides of DNA and RNA, he said they have never been reported in any amount in such spark and soup type experiments. Yet a mythology has emerged that maintains the opposite. I have seen several statements in scientific sources which claim that proteins and nucleic acids themselves have been prepared. These errors reflect the operation of an entire belief system. The facts do not support this belief. Such thoughts may be comforting, but they run far ahead of any experimental validation. Now, what he's saying is that the letters of the genetic code, the nucleotides that make up the DNA molecule, have never been produced, ever, in any spark or soup type experiments. So if you can't produce the letters, how are you going to produce the book? It's not going to happen. And indeed, subsequent studies since then have not been able to produce any evidence of nucleotides, the building blocks of DNA. Well, let's look at some other problems with the Miller-Urey experiment. Number 1, there is no geochemical evidence for the primordial soup. The only place that you will find the primordial soup on planet Earth is in biology textbooks. It does not exist in the rocks. There is no geochemical evidence in the ancient rocks on planet Earth that any primordial soup ever existed. Michael Denton, a molecular biologist, wrote in his book, Evolution, a Theory and Crisis, in 1986, he said this. He said, considering the way the prebiotic soup is referred to in so many discussions of the origin of life as an already established reality, it comes as something of a shock to realize that there is absolutely no positive evidence for its existence. It's purely theoretical. Secondly, remember I mentioned to you that O'Parent and Haldane said that the ancient atmosphere did not have any oxygen? And the reason they say it didn't have any oxygen is because you can't have oxygen and have intact building blocks of DNA and RNA. Well, recently, since the 1970s, especially since some studies done by Apollo 16 astronauts, there's been abundant evidence that's come out that's proven that the early atmosphere did have oxygen. Michael Denton, in his book, Evolution, a Theory and Crisis, on page 61, said this. He said, ominously, for believers in the traditional organic soup scenario, there is no clear geochemical evidence to exclude the possibility that oxygen was present in the early Earth's atmosphere, soon after the formation of its crust. In the 1970s, it was discovered that water vapor in the upper atmosphere is broken by ultraviolet radiation to produce hydrogen gas and oxygen gas. Oxygen gas is what we're breathing. 21% of what we're breathing right now is oxygen gas. And this process, called photodissociation, is a very efficient process. And it was accomplished in the upper atmosphere. And scientists believe now that this is a very efficient process for the production of oxygen. So there's no evidence for the primordial soup, and there's no evidence that there was an oxygen-free atmosphere in the early atmosphere. Now, this oxygen problem proposes an interesting problem as well with regards to the survival of living systems. If there was no oxygen on the early atmosphere, then there would be no ozone layer as well. Ozone is a chemical, 3 oxygen molecules bonded together, which exists in the upper atmosphere, and ozone blocks ultraviolet radiation from reaching the Earth. And this is important because if there was no ozone layer, every living system would eventually die from exposure to intense ultraviolet radiation. So if you do not have oxygen in the early atmosphere, then you also have no ozone, which means the entire Earth would be bombarded by severe ultraviolet radiation. Now, ultraviolet radiation is very destructive to, guess what? Amino acids and nucleotides. If you have no oxygen, then the amino acids and the nucleotides, which are the building blocks of proteins and DNA, will be wiped out by ultraviolet radiation. Michael Denton comments on this. He says, what we have is sort of a catch-22 situation. If we have oxygen, we have no organic compounds, the building blocks of life. But if we don't, we have none either. You see, if you've got oxygen in the atmosphere, then the building blocks made by the spark and soup are going to be wiped out by the oxygen. But if you don't have oxygen, the building blocks are going to be wiped out by ultraviolet radiation. And scientists are beginning to recognize what a problem this is for the traditional spark and soup worldview. Another problem. Remember I mentioned that the Oparin, Haldane, Miller-Urey paradigm says that the atmosphere consisted of large quantities of ammonia and methane. Ammonia and methane are fairly simple molecules, but they're absolutely necessary for the production of amino acids because they contain ammonia, carbon, and hydrogen. And it was assumed that the ancient atmosphere contained large quantities of ammonia and methane. But in the 1970s, atmospheric scientists concluded that ammonia would last only a few thousand years due to exposure to ultraviolet light. You see, with no oxygen in the early atmosphere, the ammonia gets wiped out by the ultraviolet radiation as well. They also concluded that methane, CH4, exposed to ultraviolet radiation would eventually produce a layer of oil 10 meters thick all over planet Earth. So if you can imagine the entire planet Earth being covered with 10 meters thick of oil, it would be a rather gooey environment for life to arise. And that methane is turned into the oil by destruction from ultraviolet light as well. So you can't have oxygen, but there's abundant evidence that oxygen did exist. There's no methane left after a few thousand years, and there's no ammonia left after a few thousand years. Joel Levine and Tommy Augustin, writing in a journal, Origins of Life, Volume 12, in 1982, said this. They are atmospheric scientists for NASA. They said, the methane and ammonia dominated atmosphere would have been very short-lived if it ever existed at all. Now, that's a problem because ammonia and methane are absolutely necessary to produce the building blocks of proteins and DNA and RNA. Now, another problem with the Miller-Urey experiment that is seldom discussed is the fact that the solution, the yellowy, cloudy solution that Stanley Miller produced, is extremely poisonous to living systems. Had Stanley Miller drunk the solution, he would have never been able to publish the paper that he wrote. Because the chemicals, the tar and the carboxylic acids found inside his solution are extremely toxic to cells and to enzymes, which are the proteins that accomplish all of the metabolic functions of your body. Everything from vision, digestion, hearing, taste, everything is accomplished by enzymes. And the chemicals produced, the vast majority of the chemicals produced by him are toxic to living systems. So how are you going to get the origin of life in an environment which is equivalent to the kinds of environments that the government is spending millions of dollars to clean up with Superfund? Another interesting problem is that amino acids and nucleotides, the building blocks of proteins and DNA respectively, bond to the chemical junk made in the Miller-Urey experiment far more readily than they bond to each other. Far more readily. The chemical reactions involved in combining amino acids to produce proteins and nucleotides to produce DNA are not simple chemical reactions to accomplish. They are reactions which are called endothermic reactions, for you chemists in the audience, requiring tremendous energy to accomplish. However, amino acids and nucleotides can bond with all that chemical junk, the carboxylic acids, very readily, and when they do that, it wipes them out. They become incapable of then forming life. Now, the next problem for the Miller-Urey experiment is something that was never explained to me in college, in medical school, and was one of those lightning bolt points that A.E. Wilder-Smith struck me with on that tape. And that is that the building blocks of life occur in two forms, right and left-handed. When we look at the amino acids found in living systems, amino acids are very complex molecules that have a three-dimensional structure. And amino acids occur in two forms, left and right-handed forms, and they are mirror images of each other. A left-handed amino acid, if held up to a mirror, the reflection will look as though it's a right-handed amino acid. Now, when Miller and Urey made amino acids in their Spark and Soup experiment, they produced equal portions, 50-50, of left and right-handed amino acids. Equal portions. Now, there's a serious problem with that, and that is that all the proteins in living systems are made of 100% left-handed amino acids. So if you can imagine a primordial soup with left and right-handed amino acids floating in there, how are you going to get, by random chance, by random combining of the amino acids, production of living systems which contain exclusively one type, only left-handed amino acids? It's a mathematical impossibility. It is absolutely impossible. The building blocks of DNA and RNA, called nucleotides, are made of 100% right-handed nucleotides. Again, from a primordial soup, if they could make them, which they haven't, as I mentioned before, you would not expect to reach in every time and grab out a right-handed nucleotide. Eventually, you're going to pull in a left-handed one, and it's going to destroy the structure of the DNA molecule. Now, this problem is so huge that a symposium was held in the early 1980s to figure out how in the world could living systems, which consist of 100% left-handed proteins and 100% right-handed nucleotides, or DNA, have come out of a primordial goo which would have contained 50% left and 50% right-handed building blocks. And it was determined at this symposium that it's impossible, that chance chemistry cannot explain it. We'll return to that in a little bit. I want to just point out a couple things about protein and DNA. Proteins are, as I said, long chains of amino acids. And proteins are built by adding one amino acid at a time onto an ever-lengthening chain. DNA, deoxyribonucleic acid, is built by adding one nucleotide at a time to an ever-lengthening chain as well. If you had a primordial soup consisting of 50% left-handed and 50% right-handed building blocks, the only kind of DNA and proteins that would come out of such a primordial soup would be DNA and proteins containing 50% left-handed and 50% right-handed building blocks using chance chemistry. That's the only result. If even one right-handed amino acid is inserted into the structure of a protein, it can completely destroy its ability to function. And that is why this problem is so huge to the origin of life issue. So the question is, how did we end up with proteins consisting of 100% left-handed amino acids and DNA consisting of 100% right-handed nucleotides? Chance chemistry will never produce such a mixture of 100% purity from a primordial goo which contains 50-50 left and right-handed building blocks. So how did it happen? The only way to separate the right and the left-handed amino acids, and to make sure that every time you reach into the bucket to pull out a building block, that you pull out the left-handed amino acids only. The only way to do that is by the introduction of biochemical expertise. Chance chemistry will never do it. This has been studied intensively. If you want to read about this, you can read A.E. Wilder-Smith's books. One of the best books he's ever written. The Natural Sciences knows nothing of evolution. He discusses this in great detail. The only way to separate and get out the pure building blocks for the production of life is with the introduction of biochemical expertise. And biochemical expertise comes only from a mind. Expertise, know-how, is the opposite of chance. And the only mechanism known to separate them is with biochemical expertise. Now, there's another problem that is devastating to the spontaneous generation concept, and that is something called the law of mass action. It's very simple to understand, and this is something that will absolutely derail anyone if you discuss with them the issue of the origin of life. When you take an amino acid and chemically combine it to another amino acid, you produce something called a dipeptide, which is a baby protein, and you produce a molecule of water. Now, that reaction is reversible. The molecule of water can combine with the dipeptide, and it can go back to being two unbonded amino acids. Same thing for nucleotides. You combine a nucleotide to a nucleotide, and you produce a dinucleotide and a molecule of water. Now, there is a law called the law of mass action. It's a law of chemistry which says that a reversible chemical reaction, a reaction that goes in both directions, will never go in the direction to produce something which already exists in excess amounts. Now, question, what is the number one most abundant chemical in the primordial soup? Water. Now, that means that water is going to drive the reaction not towards the right, it's going to drive it to the left, so that the vast majority of the building blocks, the amino acids and the nucleotides, will be unbonded. The law of mass action says that the reaction will never go to the right towards the production, the net production of proteins and DNA in a watery environment. So for those that propose that life arose in a watery environment by chance, they have chosen the worst possible environment on the planet, because water drives the chemical reaction the other way. If you take protein, pure protein, and stick it in water, you know what it does? The water molecule breaks up the protein. If you take DNA or RNA and put it in pure water, the water molecules break up the DNA and the RNA and drive it to unbonded nucleotides. Now, this relates to another problem of chemical equilibrium. Chemical equilibrium is something that we all can easily understand if you just think of a couple of simple illustrations. If you take a bucket of clear water and you put a drop of red dye into the bucket, that red dye will disperse over time and become very dilute. You wouldn't expect the red dye to stay as a little drop of red dye in some corner of the bucket. That doesn't happen. The red dye disperses until chemical equilibrium occurs where the dye is evenly distributed throughout the bucket. That's the concept of equilibrium. Well, if you take amino acids, the building blocks of protein, and nucleotides, the building blocks of DNA, and put them in water, what happens? Well, it turns out that the amino acids will combine and uncombine and combine and uncombine. Every once in a while, you'll get two amino acids that are bonded together. Sometimes you'll get 3 or 4 that are bonded together, but the water molecules keep breaking it up. And when you look at the solution, when it's at a state of equilibrium, once everything's been smoothed out and equalized inside the solution, that 1% of the amino acids will exist as dipeptides, which is 2 amino acids bonded together. 0.01% exist as tripeptides, 3 amino acids bonded together, and less than 1 in 10 to the minus 20th will exist in a chain of 10 amino acids. Now, this is a problem, because the smallest proteins in living systems are somewhere between 70 and 100 amino acids long. And yet, in a watery solution, you'll never get concentrations of amino acids forming long chains in a watery solution. It just does not happen. And that's because water drives the equation to the opposite direction in chemical equilibrium, which is the force, it's related to the second law of thermodynamics, drives these chemical reactions the direction to produce not long chains required to produce life, but to produce randomly floating building blocks in the watery environment. Harold Bloom in the 1950s was one of the very first scientists to recognize this problem. He recognized that a watery solution of amino acids and nucleotides, if left for millions and millions and millions of years, addition of large amounts of time does not organize the amino acids and the nucleotides to form long chains. It actually drives it towards equilibrium. And at equilibrium, the vast majority are unbonded. And in his book, Time's Arrow and Evolution, Harold Bloom said this, page 178. He said, one may take the view that the greater the time elapsed, the greater should be the approach to equilibrium, which is the most probable state. And it seems that this ought to take precedence in our thinking over the idea that time provides the possibility for the occurrence of the highly improbable. In other words, long time periods does not increase the probability that chemicals, which don't like to bond to each other anyway, will bond to each other and form long chains. In fact, he says it's the opposite, that time is the enemy of spontaneous generation. The more time you have, the more likely the solution is going to exist in unbonded chemicals. Now let's look next at the odds, the mathematical odds of the origin of life. A number of people have calculated the mathematical probability of the spontaneous generation of living systems. Harold Morowitz from Yale University wrote a book in 1968 called Energy Flow in Biology. And in his book, he calculated that if you had a primordial goo with all the necessary chemicals to form a single amoeba, a bacteria, the chance that those chemicals would come together by chance to form an amoeba is 1 chance in 10 to the 100 billionth power. That's a 1 with 100 billion zeros after it. Sir Frederick Hoyle, a British astronomer, well known for his anti-evolution views, although he is an atheist. He is an atheist. He despises Christianity, and he despises creationists, and he despises people like me who continually quote him. In the late 1970s, in the early 80s, he and some graduate student colleagues tried to calculate the probability of the origin of life. And he said in Nature in 1981, volume 294, that the likelihood of the formation of life from inanimate matter is 1 to a number with 40,000 noughts, or zeros after it. It is enough to bury Darwin and the whole theory of evolution. If the beginnings of life were not random, they must therefore have been the product of purposeful intelligence. He also said in 1981 in Nature that the chance that higher life forms might have emerged in this way by random chance is comparable with the chance that a tornado sweeping through a junkyard could assemble a Boeing 747 from the material therein. Now let's think about the odds that Hoyle and Morowitz came up with. Consider that to win the state lottery, you have about a chance of 1 in 10 million, or 1 in 10 to the 7th power chance to win the state lottery. The odds of winning the state lottery every single week of your life from age 18 to age 99 is 1 chance in 4.6 times 10 to the 29,120th power. It's not likely, is it? Now, 1 chance, you can scratch off the 4.6 there just for mathematical ease. 1 chance in 10 to the 29,000th power, roughly, the chances of you winning the state lottery every week of your life from age 18 to age 99. Now, mathematicians tell us that any event that has a probability that is less than 1 chance in 10 to the 50th power is a miracle. Anything that is less likely than 1 chance in 10 to the 50th power is a miracle. Morowitz determined that the spontaneous generation of life is 1 chance in 10 to the 100 billionth power. And Hoyle said it was 1 chance in 10 to the 40,000th power. Fred Hoyle, when he did his study, though, he only calculated the probability of the origin of just the proteins within an amoeba. He didn't even get into the DNA, the RNA, and the cell wall. So he didn't calculate the whole thing. He had so many zeros, he knew that it was impossible. He didn't continue. Now, George Wald, a biochemist from Harvard University and winner of the Nobel Prize in Biology, said in The Origin of Life in 1955, one has only to contemplate the magnitude of this task, that is, spontaneous generation, to concede that the spontaneous generation of a living organism is impossible. Yet, we are here as a result, I believe, of spontaneous generation. The chemistry to produce life by random chance is impossible. And the scientific community has admitted it. And yet, as he says, have faith, brother. I believe that I'm the result of spontaneous generation. Francis Crick, in 1981, in his book Life Itself, Its Origin and Its Nature, said on page 88, an honest man, armed with all the knowledge available to us now, could only state that in some sense, the origin of life appears at the moment to be almost a miracle. So many are the conditions which would have had to have been satisfied to get it going. He says it's almost a miracle. So let's summarize where we've gotten to this point. First of all, there is no evidence for the primordial soup. Secondly, there is no evidence for an atmosphere containing no oxygen. Third, the methane, ammonia, and hydrogen atmosphere would have lasted only a few thousand years. I forgot to mention about hydrogen. Hydrogen is so light that scientists have calculated that hydrogen would have evaporated and left the atmosphere after just a few thousand years on the early atmosphere. Fourthly, the building blocks of life would be predominantly unbonded in a watery environment. Not bonded together in long chains, but unbonded, driven that way because water molecules break the bonds and equilibrium drives the solution to be very dilute and unbonded building blocks and not products. Next, because the building blocks of life occur in right and left-handed forms, any proteins or DNA made from a primordial soup would contain equal portions of right and left-handed building blocks. Those types of DNA and proteins are called racemic, meaning they consist of equal portions of right and left-handed building blocks, and they are perfectly incapable of forming life. Absolutely incapable of forming life. And scientists know this, because if you've got right and left-handed building blocks in there, they will not form the nice, beautiful three-dimensional structures like the DNA molecule, the double spiral helix, and proteins will not form nice three-dimensional structures necessary to form enzymes, which are so important in living systems. And the mathematical odds of producing pure left-handed proteins and pure right-handed DNA is in the realm of the miraculous, according to the biologists. Now let's talk about the origin of the software. Living systems contain not only chemical hardware, but they contain software. Just like a computer contains hardware, the monitor, the box, the hard drive, they also contain software. When I bought my first computer, I was all excited. I got it out of the box. I put the computer on the desk. I plugged it in. It was a Macintosh. And I hit the on switch, and I was waiting, and I waited, and I waited, and this disk picture came up with a question mark. And it just sat there. It didn't give me the little happy face that I was waiting for.
Just stopping it here, because part 2 is carrying on from this point onwards, so be sure to go and check that out.